Let's now go back to the view controller where we can create our solar system. And just under the view did load here, I'm going to make some space. And in here we are going to create the functions that we need to make our solar system appear. So first of all, we will have a function that will be called create solar system. And this is going to do everything for us. And from this function, we will be able to call another function to create the planets. Let's make sure that we call this function straight away in our view did load. So as soon as the view is loaded, we will create the solar system like it used to be from the scene here. Okay, so in our solar system, we will need four things. First, we have our planets. Then we will have some light. We also have the stars. And finally, we will actually call this at the top. We will have a parent node to take all the nodes, the planets, the lights, and the stars inside of it. So here, there's going to be a parent node. And I'm calling this parent node, I'm creating this parent node because I want the solar system to be 1.5 meters in front of me when I launch the app. So let's first then create this parent node, which is going to be an empty node, so scn node. And then we can set the parent node's position .z to be minus 1.5 so that the parent node is now going to appear 1.5 meters in front of us when we launch the app. Okay, so now that we have this, we will be able to attach our planets, lights, and stars directly to this parent node. Fine, so let's now reuse the planet custom class that we created to create our planets. So first we will have Mercury, and it's equal to planet. And here obviously we have the construct, so if I type this correctly, we should have our construct, so yeah, name, radius, etc. Okay, so this one is called Mercury. It's got the radius of 0.14. It's got a rotation of 32 degrees. And for the color, we will just put some orange here, so orange. And the distance to the sun is going to be 1.3 meters. Now, this all looks great. However, here we will have a little problem because when you type rotations and Euler angles, etc., in code, you go from degrees to radians, and you have to use radians for this. So I'm not sure what 32 degrees is in radians, but this is something that we are going to use quite a lot. So the best way to handle this issue is to create an extension to a CG float, or an integer actually, and that's going to return a CG float in radian, and it's going to convert for us directly. So let's go directly to the end here of our class. And in here, I'm going to create a new extension for the type int. And here what we want to do is to create a new variable that's going to be called degrees to radians, which is going to be a CG float. And in here we can now return our CG float for the integer. So we cast this int, so CG float, and we pass self, which is an integer. And this now needs to be converted to radians. So the formula is to multiply by dot pi, so 314, etc., etc., divided by 180. Okay, so let's just remove some space here. And now what we can do directly in this integer 32 is just to call dot degrees to radians. And as you can see, we have a CG float as well. Great. Okay, so let me pull this up. It's quite long. So yeah, let's quickly create all of our planets with the same distances, colors, and radiuses from what we had in the scene editor. So I'm going to do this quickly, and then we can carry on with our nodes, etc. You may pause and copy all the data here that I've put, and then we will put all of these into an array. So let planets equals an array, and in here we can add Mercury, Venus, Earth, and Saturn. Okay. So now we can now create from all these planets, we will call the nodes. So we can say that for planet in planets, here the aim is to create, so we will call one function that's going to create the planets, whatever their name, radius, rotation, color, and sun distance is. So here let's just say create planet node. We'll just call actually create node, and it's going to be from, and obviously the planet here. Okay, so that's the aim. Okay, so let's just get out of this function here and create this new function that we have there. So this is the aim. Let's just copy and paste func create node from, so here we will add planet, which is of type planet, so capital P, curly brackets. Okay, so in here now, let's recreate all the planets that we made in the scene editor before. So first of all, we will have the geometry, which is the sphere. So let geometry equals scn sphere. And in here, we can make it from the radius. So that will be the planet dot radius. Okay. Now this geometry has a color, so let's just call geometry dot first material dot diffuse dot contents, and here we can pass the planet dot color. Now that we have our geometry, we can create the node to contain this geometry. So let planet node equals an scn node, and in here we pass the geometry that we just created here, geometry. Okay. By the way, if you want to rename something that you created before, you can click on Command and then click on the variable, and here you could say rename. So for example, this geometry, I know that it's a sphere, so maybe I can be a bit more accurate and say sphere geometry, or just sphere, up to you, it's completely up to you here. I like to create the variables with what they are as well, so it helps me to understand straight away what I'm looking at. So the sphere geometry is clearly not the same as a node, and I can clearly identify them. It would be very easy to just say planet, planet, but that's not what they are. Right, so our planet node has now this geometry, and we need to distance ourselves from the sun, right? So we can say that the planet node dot position .z, and here we will call the planet this planet here, and we have our distance from the sun directly from the custom class that we created. Then we can assign the name to our node. So let's just say planet node dot name, and here we can say planet dot name. And this will be useful a tiny little bit later if you bear with me just one more minute. We have a rotation as well, and if we rotate this planet, it's just going to have a rotating ball, like as if you were rotating a basketball on your finger. That's not what we want. We want to rotate, we had a parent node that would have actually the rotation of the planet around the sun. So let's create a parent node, just like we did for the solar system. So it's an SCN node. And then we will attach, so this one is going to be positioned exactly where the sun is, and it will bear the rotation. However, this planet node is going to be distanced from the sun and will rotate, therefore, around the sun. Okay? So what we can do is to attach directly this planet node to our parent node. So planet node dot, actually is the other way around, so parent node dot add child node, and in here we can pass our planet node. Okay, now here for the rotation we will need to create an action. So if you remember, we had to drag and drop an action in the scene editor. So this is pretty much what those 2 lines of code will do. We'll just create a rotate action, and guess what? It's an SCN action, and here you can say dot, and you will find a few of them here. So what we are interested in is rotate, and you have different ways to do it around a vector, etc., etc. We can just call this very simple one here that will say how much we want to rotate. So the x-axis is going to be 0. The y-axis, however, is going to be our planet dot rotation. And for the z, we can just say 0 as well. Okay, and duration is 1 second. So every second is going to have a rotation that we specified here, and obviously earlier over there. Okay, so we have the rotation, we have the sphere, we have the color of the sphere. What else are we missing? Oh, by the way, so the distance for the planet, we will just do a minus here. So that's going to appear in front of us when we launch the app instead of behind us. We won't have to wait for them to rotate to appear in front of us. I actually forgot to call this action directly on the parent node. So very simply, we can call this parent node and just say run action. So this action is actually going to be run only once for 1 second. So here we can call our rotate action, but that's not going to be enough. So what we can do is to say dot repeat, and here you can see we have repeat forever, and this is where we can call our rotate action. These are actually more powerful in code because you can do a bit more than you would do. You can do some reverse, you can do some, you can do quite a lot of things, and we'll probably see this later in the course. Rotations are quite easy, and I just wanted to show you that in a couple lines of code you can add actions and animations to your nodes. Okay, so we have our parent node. This function, I want actually to return a node, so we'll just call this return here, and it's going to be an SCN node. So in here I need to return and obviously it's going to be the parent node because we've got the planet node that's attached to it. So return parent node. Okay, so we might come back later actually to add some rings to Saturn, so that would be a specific case for Saturn, but otherwise I think we're pretty much done here. So every time we create a node here, you can see that the result from that is unused. So what we can say is that we can add, so we will add this to our parent node that we created here. So let's call this parent node dot add child node, and this is going to be create node from the planet that we created just here. Okay, so that's gonna loop through for each planet, so that's gonna run 4 times and use all the data that we've got in here. So that's good. Our planets are done. I will stop the video here, and next time we can have a look at how we can create some lights and some stars as well.